Hey, geometry students. In this lesson, we're going to be talking about spheres. All right, and a sphere is simply a set of points in space that are a fixed distance away from a given point. That's the geometric definition. Now, interestingly, when you ask people for their definitions of sphere, a lot of people will say that a sphere is the set of points that are less than or equal to a fixed distance. Or, in other words, they describe a solid sphere. But in our geometrical definition of a sphere, we're talking about the set of points in space that are a fixed distance. We're talking about a hollow sphere. This would be like a basketball. A basketball has an outer layer, but that layer is filled with air on the inside. So if we were not to count the air in the inside and just that outer layer, that's what I'm talking about with a sphere. The center of a sphere is the given points from which all points are the same distance away. The radius of a sphere is from the center point. Okay, so it has two endpoints. One is the center of the sphere, and the other is any point on the outside of the sphere. Because remember, all points on the sphere are the same distance away from the center. So that's how you find the radius. And then we have another term. Hemisphere is half of a sphere. And a great circle is a circle that divides the sphere into two hemispheres. In other words, a great circle is a circle that you can draw on a sphere that has the largest radius possible. It goes all the way, the farthest distance around the outside of the sphere. That's a great circle. If you ask me, they're not that great. All right, anyway, we're going to be using two formulas in this lesson, and that's what makes this lesson easy. Like, yeah, we have a lot of terminology, and we're going to be thinking about spheres, but these equations are so simple and straightforward. I don't think you're going to have any struggles with using them at all. The surface area of a sphere has an equation 4 pi r squared. The volume of a sphere is 4/3 pi r cubed. Now, just a quick warning. A common mistake that students make is when they're not used to using r cubed in equations. So sometimes students will accidentally use r squared. Watch out for that as you go. Make sure you're using the right equations. And we're going to see just how easy these problems are. All right, so letter A. Find the surface area of a sphere with an 8-meter diameter to the nearest hundredth of a square meter. So the surface area of a sphere is simply, let's just get this right here, S equals surface area equals 4 times pi times the radius squared. And our problem says our diameter is 8 meters. We need to find the radius. The radius is going to be half of that. So this is going to be 4 squared. Well, 4 squared can just be simplified to 16. But here's an interesting thing. This is 4 times pi times 4 squared. Or I could simplify this even further. This will not happen with every one of these, but it could be 4 cubed times pi. I know what 4 cubed is. It's just 64. So this one ends up being 64 times pi if you simplify it. Or if you want to do it the long way, it's 4 times pi times 4 squared. All right, let's just pull out a calculator and see what 64 pi is, because we need to get this one to, let's see, 201.06 to the hundredth. Okay, so let's see, it was 201.06. Let's see how good my memory is. I think I already forgot what the correct answer was. That's going to be in meters cubed. Let me just double check. 201.06. Yes. Okay, and let me just double check that we got the same answer as in the book. Now, I wonder what they did differently. We're really close. We're only off by a tiny amount. 64 times pi. I wonder if I use 3.14 instead of pi, if I get the same answer as them. This is a worse way to do it. But let's see, 200.96, 200.96. All right, so somebody at Saxon Math Incorporated accidentally used 3.14 for pi in this one. That is not an accurate way to plug pi in when you're asked for pi, because you have the ability to use a calculator. It has an infinite number of digits of pi. So I'm going to encourage you not to do what the book did. Do what I did. They're going to get a better answer as a result here. Letter B, find the volume of the sphere shown, that's this sphere over here, to the nearest hundredth of a cubic inch. Volume is 4/3 times pi times the radius cubed. In this case, the radius is, well, half of 22, so 11 cubed, okay? 4/3 pi times 11 cubed. Now, there's no way I'm doing any part of this without a calculator. I don't know 11 cubed off the top of my head. Let's go ahead and do this one. So it's going to be 4/3 pi times 11 cubed. And I'm just going to punch in everything exact. 4/3 times pi times 11 cubed. And I get 5,575. 5,575.28. So we're just going to write that number down here. 5,500 and peak 75.28. And again, let's see, nearest hundredth of a cubic inch. This is in inches, so it's going to be inches cubed. And let's make sure. All right, now, hey, I just noticed something really dumb that I did. How is this one cubed? This was an area. So this one's not going to be in cubic meters. It's going to be in square meters. That was a really good catch. And then this one's going to be in cubic inches. Let's make sure we got this one right. 5,575.28. Oh, looky. All of a sudden, our good folks at Saxon are using the exact value of pi again. All right, letter C. Find the surface area of a hemisphere. Now, the surface area of a hemisphere is one that's easy to make a mistake on because there's a part that people tend to forget. For a hemisphere, I want you to imagine we're cutting the sphere in half. We're going to have the outer spherical part that we need the surface area of, but also this inner circular part, because there's going to be a circle. If I cut this in half, there's going to be this solid, and it's a solid sphere, there's going to be this circle that I need to find the area of as well. So what I need to do is add half the volume of the sphere to, I have the surface area of the sphere, to the surface area of the circle that has the same radius as the sphere. Okay. And again, it's just because when I cut it in half, what's going to be exposed to the outside air? The outer curved edge of the sphere, but also where I cut it, that flat circular surface as well. All right, so a 16-foot radius to the nearest hundredth of a foot. So the surface area is going to equal, let's see if we get this right here. Surface area equals 4 pi r squared plus, okay, I'm going to put a space there. Okay, and then this is going to be plus, and then let's see, I need to add an extra area of just the circle. That's going to be pi r squared. Well, here's an interesting thing on this one. 4 pi r squared plus pi r squared. Wait a second. We need, because it's a hemisphere. Okay, so this 4 pi r squared is giving me the surface area of the whole sphere. I need to take this and divide it by 2, so I get half the sphere. But then plus another pi r squared. When I add these together, the surface area of a hemisphere is actually 3 pi r squared. That's pretty wild, isn't it? Because you wouldn't expect that it's going to, like, you have this curved surface and this flat circular surface. You wouldn't expect it to come out that simply, but let's see if it actually does. So it's going to be 3 times pi times 16-foot radius. That's 8. I'm sorry, it is 6. I'm going to leave it in 16 because it's the radius already. It's not a diameter. Read the problems carefully. 16 squared. Okay, and let's see if that gives us the right answer. 3 times pi times 16 squared. 3 times pi times 16 squared. There we go. And we get 2,412.74, 2412.74. Let me just write that out. 2412.74 inches squared, feet squared. There we go. All right, let's see if we did that one right. All right, so, I was supposed to find the volume too. We could do that in a second. So the surface area, though, I'm right on. The volume is super easy because for the volume, it's just going to be half of this equation. Hey, how do I make a fraction half of that fraction? So instead of 4/3, I changed the denominator here to 4/6. 4/6 is half of 4/3. 4/6 is actually 2/3. 2/3 is also obviously half of 4/3, actually, now I think about it. So it's going to be, for a hemisphere, instead of 4/3, it's going to be 2/3 times pi times the radius cubed. That's going to be 16 cubed. Okay. 2/3 pi times 16 cubed. 2/3 times pi times 16 cubed. And we got 8,578.64, 8,578.64. So we know how to do these problems. On to the next one. Letter D. A snow globe's circumference is 20 centimeters. How much water does it take to fill the globe to the nearest hundredth of a cubic centimeter? So we're looking for volume, water to fill the globe. But they are making this all sorts of hard because instead of giving us a diameter, which we can deal with, or a radius, which is the easiest, they give us a circumference. Okay, so we need to remember that the circumference equals 2 times pi times the diameter times the radius. Because pi times the diameter is 2 times the radius. So I could do 2 pi r. All right, so we need to take this circumference. 20 equals 2 times pi times the radius. Or, let's see, the radius is going to equal, if I get the radius on a side by itself, 20, divide both sides by 2. So that's going to change this to 10. And then divide both sides by pi. It's going to be 10 over pi. If you don't believe me, do this on paper and check to make sure you get the same thing. When you get the radius on a side by itself, you're going to divide both sides by 2. That changes to 10. Divide both sides by pi. So I'm going to do 10 over pi to get my radius. Okay, 10 over pi is 3.183. I'm just going to record that many decimal places for now. 3.183. We'll round to the hundredth at the very end. All right, now I have my radius and I can calculate my volume. The volume is 4/3 times pi times the radius cubed. So what I'm going to do is I'm going to just take my radius here, cube it, and multiply it times 4/3 pi. So I'm going to say we're going to raise this to the third power. Okay, so I cubed my radius, and I need to multiply times 4/3 times pi. There we go. After that fancy calculator work, we have 135.09. So equals 135.09. And that's going to be in cubic centimeters. Let's see if we did that right. Now, here's the thing. There's going to be rounding error in here because I kept my number exact. I didn't round it off to 3.183. I wonder if I would do 3.183 cubed, okay, times 4/3 pi. Do I get exactly the same thing they got? No. But I'm guessing that this is, maybe that's the other thing that we could do because we know that they were culprits using 3.14 earlier. I'm not sure why their answer is a little bit lower than mine, but as long as we did this right, then let me just double check my radius one more time here just to make sure 3.183 is correct. So it's just going to be 10 over pi. I'm guessing that there's just some rounding error here, and we're both right, 3.183. So I'm sure that we've just rounded at different spots, but this is a correct answer. This is also a correct answer. Maybe the problem is that they rounded to 3 point. Let me just indulge me. I'm going to check one other thing. So if I change it to 3.18, there we go. So if I round it just a little bit more, I can get the exact same result that they got. They rounded a little bit early. I always encourage people not to do that. Only round your number at the very, very end. But either way, at least we figured out we did do it correctly. That's how you use these equations to find the surface areas and volumes of a sphere. You should be able to do the problems for next time.